In mathematics, especially in calculus, understanding how functions behave is essential, and one of the most important concepts is continuity. A function is said to be continuous if you can draw its graph without lifting your pencil. A function f is said to be continuous at a certain value of x if there is no break, no jump, or no hole in the graph at that point. This continuity of a function helps us understand how smoothly a function changes, and it's a very important foundation for many key concepts in calculus such as limits, derivatives, and even in integrals. So by learning how to determine whether a function is continuous or not at a certain point, we are able to get a better understanding in its overall behavior, both algebraically and graphically. So we can say that a function is continuous at x equals a other than knowing that there are no holes, breaks, or jump, or that we can draw the graph without lifting a pencil. By technical definition, we can say that a function is continuous at x equals a if these three are satisfied, these three conditions. So the first condition is that f of a must be defined, that the limit of f of x as x approaches a exists, and that the limit of f of x as x approaches a is equal to f of a. So meaning the first two must be equal. So if if one or more of these conditions of the definition is not satisfied, then we can say that f is discontinuous at x equals a. So there are three types of discontinuity of functions. So the first one is the jump discontinuity. So as we can see here, the one-sided limit of f of x as x approaches c here, they both exist but they are not equal. So this part, this is the limit that the function approaches, but on this part, this is the limit that the function approaches. So because they are not equal, then the three conditions are not satisfied. So this type of discontinuity is the jump discontinuity. Another type of discontinuity is the infinite discontinuity. So the one-sided limits of f of x as x approaches this value c are infinite. So this increases indefinitely upward. And so because it is not defined, then we can say that the function is discontinuous at x equals c. Because a violation of the second condition for the continuity of functions. And then we have the third type of discontinuity, which is the removable discontinuity. So here we can see that the function is defined at x equals c, and that the limit of f of x as x approaches c exists, but these two values are not equal. It exists, there is a value here, but they are not equal. So therefore, the third condition is not satisfied. This, again, discontinuity is called the removable discontinuity. So how do we determine the discontinuity or continuity of a function? So first, we have to check the domain of the function or the allowable values of x, those values of x that will make f of x defined. Then we look for the points where the function is undefined. Usually if the function is rational, so the only time that the function will be undefined is when the denominator is 0, or if it involves radicals, when the radicand becomes negative if the index is even. And then if necessary, we use the limit definition, the second one. And for piecewise functions, we check continuity at the boundaries. So for example, or okay, so when we express our answers, if we are to find the continuity of functions, so we can use a statement form that the function is continuous for all real numbers except a specific value or specific values of x. Or we can express it in interval notation in this form. So for example, we are given the function f of x equals x cubed minus 2x squared minus 3x plus 1. So this is a polynomial function, and the graph right here is the graph of this function. And as you can see, this extends indefinitely towards the left and also towards the right. And you can draw this curve right here without even lifting your pencil. If you have no idea how the curve looks like, just by looking at this function right here, we can say that there is really no value of x that will make f of x undefined. Therefore, we can conclude that a polynomial function f is continuous everywhere or at all values of x. So f, in an interval notation, f is continuous at the interval negative infinity to positive infinity. So again, for polynomial functions, there is no value of x that will make this function undefined. And then we go to this function, a rational function. F of x equals 1 over x minus 2. So for the graph of this function, we are showing it here, this is cut along this value of x right here, which is x minus 2. Now, how do we know if we don't know how the curve looks like? How will we know at which value of x it will become discontinuous? So just by looking at the function here, this f of x will be undefined when this value of x right here in the denominator becomes 0, because any number divided by 0 is undefined. So therefore we can say that this function right here, f of x, is discontinuous at x equals 2. And f of x is continuous at all values of x except x equals 2. And that statement can be shown in this interval notation, negative infinity to 2 union 2 to positive infinity. Now, how do we know how to express it in an interval notation? So what we're gonna do, if you find it difficult, then you can draw the number line. If this is 2 right here, it should be a hollow because 2 is not included, because this is a break right here, because the function is discontinuous at this point. So meaning all values of x that are greater than 2 going to the right, and all the values of x that are less than 2 going to the left. So if 2 is not included, open interval, then we are going to use the parenthesis. So all values of x that are greater than 2, or all values of x and all values of x that are less than 2. So only excluding